Is it not? So in this architecture now, you will see that there are few more blocks. Now, one thing you can also think and tell me, how does the speed of the processor increase? Anyway, I will come to that point, but till now, little whatever you have understood from whatever you have read, how does the speed of the processor increase? I told this point every time I was talking about processor. You also think, try to recollect what we have discussed. How does the speed of the processor increase? Then only you will enjoy listening to the lecture. For every advanced version, how it is getting advanced, that you should know. So by what means? Guess, somebody can guess. What, Geeta? You have to answer this
Then,
question. How does the speed of the processor increase?
with the help of pipelining.
Right, yes.
Because in 8085 there is no pipelining.
Yes,
8086
yes, yes.
pipelining queue is there.
Very good, very good. Yes. Some more parameters are there. Somebody can try. Other than Geeta, also somebody can try. How does the speed of the processor increase? See, we are all using our laptops, our smartphones. And when we go to buy a laptop, are you buying by the beauty of that piece, or you are buying by specifications? Yes, some people are still joining. My question is, how you are buying any software device, whether it is your smartphone or your laptop, by the beauty of the piece, by the slimness of the piece, delicacy of the piece, or specifications. Or you did not buy at all in all these days. Yes, people, somebody has to answer this. Okay, another, on the same line, I will put another question now. 8085 processor, what was the data bus of 8085 and what was the data bus of 8086? I am giving in a way an indirect hint to you. This means that you are not reading.
Multitasking and hardware.
No, I asked. Now the question has changed. To take you to my answer, I have put a question in a different way. I am asking you what was the size of the data bus in 8085 processor, in 8086 processor.
In 8086 16-bit data bus and 8085 8 bits, right or wrong?
Excellent, excellent. Very good. So some memory is there, right? Excellent answer. So see now, if I told this point, try to recollect. If the size of the data bus increases, then the execution will be faster, no?
Yes, ma'am.
So the speed of the processor will depend upon the data bus.
Data bus.
Another one more point. See, now when last time in the class I told you that if the size of the data bus is more, execution speed will be more, because you will take less number of machine cycles to execute the instruction, and a program is a set of instructions, is it not? So when all the instructions are executed in less time, the speed is increasing. So it is so simple. Then, so one is the first answer which you said, multitasking feature or because of pipelining in the 8086 processor is an advanced version of 8085. And other than that, your data bus is also more in 8086. And because of the larger data bus, execution time is also decreased. See now our smartphones, if we touch the screen only, we want the application to work for us. We cannot wait for a few milliseconds also. We want everything at the rate of nanoseconds. Is it not? Now in the laptops also you have got touch screen boards, keyboard. So all these how the smartness of the device is going on changing. It is increased, the speed itself is increased for every operation which we are going to perform. Now another one more feature which will be important in advanced pieces, you will the clock cycle. So if the oscillator frequency is more frequency means it will take less time. The clock cycle will be less. So if the clock cycle time, the time period of the clock cycle is less, then also the speed will increase. Is it not? So there are three things which increases the speed. Now see, imagine you are having a time period of 1 second. 1 second time period in the present day for all of us is too big a time. It is as if we are waiting for 1 hour. The same thing, 1 second, if you can convert it into a nanosecond, then we will feel, oh, it is the speed has increased. Yes or no? So like
Yes,
this, the speed of operation, that is the crystal frequency or the oscillator frequency or the clock of that particular processor, if the clock speed is increased, if the data bus is increased, if the pipelining feature is increased, with all these parameters, that particular device will operate at a faster rate. The speed will be more for it. So now how is your 80286 an advanced version? That is the point there. So now in this also the data bus is 16-bit, but as you said, pipelining feature, there is a small modification in the pipelining feature in this case. And the address bus and the data bus in 8085 and 8086, it was time multiplexed. It was time multiplexed. Means they are using that same bus for both the purposes. Initially as an address bus, later on as a data bus. Now in the 286, they have separated address bus and the data bus. So they are having separate lines which will carry the address, and they are having separate lines which will carry the data. So earlier you said it is time multiplexed bus, address and data bus. But in this case, 286, they have demultiplexed buses. Demultiplexed means you are having separate address and separate data bus. So that is why you will have to use these words very carefully when you are dealing with each of the processors. So when you are preparing, you have to see what are the features of 85, what are the features of 86, what are the features of the other advanced processors. So generally, after 8086, there is 80186 is also there, but in your syllabus it is not there. 80286 is there, 386, 486, like this. Each version will be an advanced version of the earlier processor. Okay, so now I'll share my slide and then you can see. In this today's this thing, I wanted to merge the figure, but somehow it did not work out. So initially we will see the features, then we will look into then I'll show you the block diagram also. So hope you can see the slide.
Yes, ma'am.
So my heading is gone. So as I said in the past few minutes that it is the advanced version of 8086 processor. Now, as we will go into the one by one advanced feature, you will like how one by one step the advancement has taken place in the processors. Now nobody is using 286. So since our syllabus is very old syllabus, which is not modified, so you have to study this one. And because question paper will also contain some questions of like this. So that is why we have to study. So first point is it is an advanced version of 8086 processor. You have to remember slightly about 8086 processor also, so that here and there I will bring the reference so that you can also make a note of all such things, because all points will not be there on the slide which will be presented here. So when we say it is a 16-bit processor, the second point is it is a 16-bit processor. By 16-bit processor means the data bus is 16-bit. I told this point earlier also, again it is repeated. 8085 is a 8-bit processor. 8086 is also a 16-bit processor. Now this is also a 16-bit processor. Then see here, earlier processors were 40 pins. Here it is 68 pins. Just now I said that the address bus is 24 bits or 24 pins are there and 16 pins of data bus. So you can see address bus in 8086 was 20 and here it has become 24. Similarly, data bus remains the same, but you are having demultiplexed, means separate data bus and separate address bus. So that is why naturally the number of pins also will increase. So since it is a 16-bit microprocessor, we can say that it has the ability to execute 16-bit instruction at a time. So it is not taking place first 8 bits and then 8 bits. If you are adding two numbers whose size is 16-bit, directly you can add those 16-bit, like A plus B means A is also 16-bit, B is also 16-bit. So it has the ability to execute 16-bit instructions at a time. Then this point is important now. It is 6 times faster than 8086 microprocessor. So approximately they have given how many times it is faster. So you can imagine that how fast it could be when compared to your 8086 microprocessor. So it is 6 times faster than the 8086 processor. And this point also you can see the instruction set of 80286 includes the instructions of 8086 and 8186. So what all instructions were used in 8086? They are there. Along with that, some extra instructions are there which will support the operating system and the memory management. So generally when you are using your laptop or your computer, frequently after some few months or approximately 1 year, you will get some updates. So on the cell phone also you will see updated software, all these things you will be getting. So now and then what will happen? Some features will be included in that only in your old um, structure, like or the software which is there. So some new features. So if only the software is updated means some program or something can be directly downloaded from the cloud and it will work for us. Now, the instruction set has the instructions of 8086 means if you are trying to run any program which you have already done on 8086, that same program should run on your 80 to 86 also. So that feature also has come in one of the processor, not in 80 to 86. It will come, I will tell you when I am coming across that point. So the instruction set which you have used for 8086 remains the same. Along with that, some more extra instructions are also added so that it will support the operating system and the memory management. Now, next point is it is optimized to execute instructions in fewer clock periods than 8086. So, just before starting, I said if the time period of the clock pulse or the oscillator frequency is increased from, let us say, from 5 kilohertz, it becomes 5 megahertz. So you have increased the frequency. So if frequency is increasing means time period of the clock pulse will decrease because frequency is inversely proportional to time period. So that is why with the increase in the frequency, the time period decreases, as a result of which the instructions will be executed faster. So in this case also, you are having that the uh, time period of the clock is further increased when compared to your 8086. So when we say it is a 16-bit processor, it is understood that the data bus is 16-bit. So any one point if you write also it is understood. If you are having time, you can write both the points also. Then the size of the address bus is 24 bits. So 2 to the power of 24, how much it will be? Just calculate on your cell phone and one of you can tell me. The address bus is 24 bit. So the size of the memory will depend upon the size of the address bus. And size of the memory is calculated as 2 to the power of 24 in the present case. Use your calculator or cell phone and tell me how much will be 2 to the power of 24. Yes, anybody can try and tell. Similarly, how much is 2 to the power of 20? Do it on your notebook and write it there and you keep there. 2 to the power of 20, 2 to the power of 24. How much is the value? Yes, somebody is doing or no?
16 megabyte.
Right, excellent. 2 to the power of 24 is 16 megabyte. Similarly, 2 to the power of 20.
Mm,
Ma'am, 2 to the power of 20 means 10 lakhs 48,500.
10 megabytes.
How many megabytes? Ten megabytes. How much?
10 megabytes.
Your 8086, how much was the addressable memory?
16 megabytes.
No, it is not 16 megabyte.
24. 24.
Just now you said no, 10 megabytes
Yes, ma'am.
or 1 megabyte. It is 1 megabyte only.
1 megabyte only, ma'am.
1 megabyte only. Right. So, very good. You are active after lunch also. That is so nice. So, how, and then one more point I have to ask you. Your 8085 was, address bus was 16. See how much is 2 to the power of 16? $65,536, no? On your cell phone, you can do rejoin again. Cell phone is having calculator, no? Everybody is having smartphone now. Or at least somebody who is having smartphone can check. Calculator option is there, no, in that? Provided your cell phone is having. So 2 to the power of 16 for 8085 processor, you can write in your notebook or on a piece of paper and keep.
65,536.
But when you write in kilobytes, you will write is 64 kilobytes.
Yes, ma'am.
So see now, 8085 was, memory size was only 64 kilobytes. Kilo. 2 to the power of 16 it was. You increased 4 wires, 2 to the power of 20, it became 1 megabyte. Now again after that we have increased 2 to the power of 24, 4 more wires in your address bus. So it has become 16 MB. See, one wire makes a difference there. Is it not?
Yes, ma'am.
1 megabyte in 8086, I said you are having the whole memory was divided into even memory and odd memory. The address bus, like for the 16-bit address, if it is having, you are having memory location, the total 1 MB was divided into two parts as 512 kilobytes and 512 kilobytes. Is it not? So one 512 had all the odd addresses, another 512 had all the even addresses. So like this, the memory was divided there. Now, by dividing the memory also, it is trying to increase the computation speed. How it is happening, I will tell you that little later. But one thing which you have to remember is, if the size of the data bus is increasing, speed is increasing. And size of the address bus is increasing, the memory space will increase. It is like 100 pages notebook and then 200 pages notebook, 100 pages notebook, it will have 100 pages. 200 pages notebook will have 200 pages, is it not? So there we are counting by pages. Where in the processor, it is the capacity, memory capacity is decided by the address bus there. One more point which you might have noticed or not noticed, I don't know. All your laptops, in the 64-bit processor, they will not say data bus is 64. 64-bit processor they will say. Memory size 1 terabyte they will say. Is it not? You must have come across all these words, or if you have not come across also, you can look for the specifications of your laptop, or you can ask your people who have a knowledge about the specifications. So in that you can see 64-bit processor means your data bus is there 64. So that is why the speed will be so much. It will be very large for all your laptops or cell phones. Cell phones will also have their own data bus and address bus. But we are interested in only some of the usage of that device. We are not looking into the specifications. So when you are buying the laptop also, if you want larger speed means 32-bit, 64-bit, 128-bit processor, like this, you have to look for your data bus there. So if the data bus is more, then the speed will be more. And if the address bus is more, then your memory is more. But in your laptops, 4 MB RAM is there. If you want to increase, we will buy 4 MB extra and then we will insert that particular RAM for the larger memory space in your computers. That is what is done generally. So this microprocessor, being the advanced version of 8086, it is designed for multi-user and multitasking. Now, multi-user means you can have more number of users from the literal meaning only. Don't confuse between multi-user and multitasking. Multitasking means you can have lot many things. See, you on your cell phone also, you can have the camera which will take the photos. You can have the YouTube which will run some songs or videos for all that. You also have the MS Word feature in which you can type the documents. You can also edit the documents. So all these are the different tasks which a single cell phone will be doing for you. So that is multitasking. Multi-user means many number of people or clients can still use one particular master processor. So multi-user meaning it allows access by multiple users. So now if the link is there, all the students will try to open the link and then check your marks. Is it not? So all these are multi-user facility. From any corner of the state or any corner of the country, people can access that. So there a multi-user facility is provided. So that is how multi-user and multitasking would be different. So that also is, although I have mentioned it, it is not necessary when you are writing about the features. You can simply say that it is designed for multi-user and multitasking. So just now, as I said, multi-user means it allows access by multiple users of a computer. Multitasking is you can, on a single piece, you can perform playing the music, editing the documents, surfing the Google Chrome. All these are the multitasking features which you can have with your processor. So but at any time, see, this point is again interesting. At any time, the CPU is executing only one task and other tasks will be waiting for their turn. It is as if they are waiting in a queue for. But for a user, it doesn't appear that the other tasks are waiting in the queue because of the speed of operation of the processor. So all the designing of the processor, how the speed can be increased, how the technology is increasing is, it increases the development of the technology is such that it will try to increase some feature or some parameter of that particular device. So that is how it is. So although the CPU is performing only one task, the other tasks are waiting for their turn in the queue. But the illusion of the parallelism is achieved when the CPU is reassigned to another task. That is, all the three tasks ABC are appearing to occur simultaneously because of the time sharing feature in that. So this also, simply for you to understand, I have put that point, but you can not necessary to mention in an answer sheet all these things. Now, we just now said that it has got same instructions as 8086 with a few additional instructions which will control the memory management. So this memory management, one particular term is there. This we will see a little later how that memory management is being done. Now, in this case, like your 8086, it is also having 16-bit flag register in which only 12 bits are assigned some work and 4 bits are unused. So in the 8086 also it was same case. Now next one is 16 megabyte of physical memory with your 24 address bus. 16 megabyte memory is possible, but 1 gigabyte of virtual memory is also present, and that will be used by the memory management system. That particular feature of this 286, it has got memory management unit. So with that it is able to access even the virtual memory. So if some program is very large or you are trying to open many windows, so it has to run all these programs, is it not? You are not every time resetting anything, or you are not closing any window. So whenever it has to use, means it will not overwrite on that. If the memory management system is there, it will try to use that many memory space. So it contains the memory management unit. Because of that, the virtual memory can also be used. So generally you will have what is known as SSD RAM. You might have heard SSD RAM. People who are from the computer background will also know about this SSD RAM. So that will be your virtual memory sort of thing. I think all this may not be needed for you. This is simply for you to understand. So when they are using that virtual memory or using that SSD RAM, 1 minute, I'll just come back. So for your virtual memory, they are using some swapping technique sort of a data. The swapping is you can use this memory in place of your actual running memory. So all these things, what are the major points in this address bus, data bus, flag register, and then why it is a advanced version of 8086, all these points you try to cover when you are writing the answer, because what all I am telling, all so much you may not have time. So generally when they are asking about the block diagram of 80 to 86, so as I asked in the beginning only, 8086 it has got two blocks. That was bus
Bus
interface unit and your
execution
unit. Now in this 80286 you will have four blocks. So now I will show you that figure. I am stopping this and I will show you that figure because I could not get time to merge that one. That is why this small complication has come. Now see this figure and try to identify the four blocks which just now I was talking about. So I said it has got four blocks: address unit, and then bus unit, instruction unit, execution unit. So or you, if you are having material by your side, you can see that also. First you feel that figure, then we will go into the discussion. There are four blocks in this. In 8086, we discussed about the two blocks, BIU and EU. Now here try to identify the four blocks: address unit, bus unit, instruction unit, execution unit. Or you try to keep the material by your side, in that also that figure is there. If you are able to identify, then you tell, we will proceed again. So you can see in the figure, did I share? Right. Students, please see. Sorry, I thought I am sharing, but I forgot that I did not share. So if you are having the material in that also you can see, otherwise you can see on my screen also. Just check the 4 units: address unit, bus unit, instruction unit, execution unit. Are you able to see the figure?
Yes, ma'am.
Are you able to see the 4 blocks?
Yes, ma'am.
What, only Geeta is answering? There are no other students? No response?
Yes,
Right. So now see what I am telling. You try to see the figure also. So now you are having 4 blocks in this, no? How the 4 blocks will work to execute your program, that we have to see. What we have to see? The working of, initially I will tell you in a very brief way. In exam, if you have to write the answer, then you have to write about each block, how they are functioning and how the execution will take place, right? So initially you see, try to see the figure, the address unit. Now last time, see, bus interface unit which was there in 8086 processor, it was interacting with the input output devices and memory. Bus interface unit, BIU. So bus interface means it is interacting, it is interfacing. Interfacing is the language of your processor. But if we talk in terms of interfacing between people, means it is interacting. So that is what it means. So in this, now the address unit, what it will do? It should generate the physical address. So last time also 8086, I told you what is physical address. There was one small relation. So the segment register will hold some address, and then the offset address will also be there. And from that, it will generate a physical address. And that physical address, it should send on the address bus to the memory for it to fetch the instructions. Same work is done here also by your address unit. The address unit, it generates the physical address of the memory, right? So this is same whether you are seeing 8086 processor or you are seeing 286 processor. So it is generating the physical address of the memory. Now, after it generates, it has to put that physical address on the address bus. Is it not? Why it has to put that on the address bus? So that it will go to that particular location. Go to page number 10 means everybody will see page number 10. No, what is there on that? So similarly, here I am saying page number 10. But for a memory, it will be an address. So that is put on the address bus. So after it is put on the address bus, it should go through the bus unit. From the address unit, the work of address unit is only to generate the physical address. So there in that particular block, you can see their offset adder, segment limit checker, segment basis, segment size. So you had 4 segment registers in 8086. Same registers are there here also. Those were also 16-bit. This is also 16-bit. There is no change in that. So the main function of your address unit is to generate the physical address of memory. Now, if it has to go till the memory, those address has to put on the address lines. That work will be done by the bus unit. Bus unit itself has that particular work, or its function is to put the address on the address lines and go to the location of that particular address in the memory. From there, it has to fetch the instruction and the data. So what all programming when you do, when you say move a comma and some number, let us say 0, 5H. So move A will have one code. You have done programming already. And then the data, the what you call that? It is missing from my memory. Opcode and operand. Opcode is move A. Operand is your data. So directly the data may be present in that, or you may have the code for the location from where the data has to be taken. It could be, so you, just as you have different addressing modes. So the work of the bus unit will be to put the address on the address line, to fetch the instruction or the data from the memory. Is now the work which the bus unit has to do. Now see there, after it gets the instruction or the data or the code for the instruction and the operand, what it will do, what it has to do. So initially you see, directly all that instructions will not be executed. All first when it is going to the memory location and fetching, you see in the bus unit at the down 6-byte prefetch queue, one block is there. 6-byte prefetch queue means 6 bytes from the memory will be stored in this. In your 8086 also you had prefetch. If you can remember that, you had there also some option like prefetch instructions. There also it was 6 prefetch stack was there, so that from the memory 6 bytes will be kept ready always in the bus unit. Then from the bus unit, this 6-byte prefetch queue, each byte one by one after another, it will come to the instruction unit. So in the instruction unit, there are 2 blocks. See properly, what are the 2 blocks there?
Decoded instruction queue and instruction decoder.
So you see there, the arrow is coming from 6-byte prefetch queue. Is it not?
Yes,
so it is as if you have kept one stock of 6 bytes in that block, and then 1 byte is coming to instruction decoder block. One after another they will come, but it is coming first to instruction decoder. From there, the decoded one is going to be stored in 3 decoded instruction queue. So it is decoded, and again it is like they are all waiting for their turn to come. 3 decoded instruction queue. At a time, 3 will be there. And then from that decoded instruction of the instruction unit, they will then move to the execution unit. So once the decoding is done, now it has to be executed. So the execution part will be done by the execution unit. Now in the execution unit, there are only 3 blocks. You can see. What are the 3 blocks?
ALU,
registers and
control.
What is this ALU?
Arithmetic logic unit.
Oh, very nice, very nice. So everybody has become now perfect in block diagrams. That is nice of you. So now every time the execution unit has the work of executing the instruction. So see here, fetching is done at one place, decoding is done at another place, execution is done in another place, right? And then now one more point here to be pipelining feature, which we have seen in the 8086. There it was fetching and executing. There were 2 steps, 2 levels. It was fetching, there only it is decoded, and then execution. But here, once that 6-byte prefetch queue, that becomes empty, another 6 byte. So at one side fetching will go, another side decoding will go, another side execution will go. So once one instruction is fetched and decoding is taking place, one place will be empty. So it will again get another one more byte from the memory. So all these three things, fetching, decoding, execution, all this can go simultaneously. So it is a 3-level pipelining system here. So every time there is place, the fetching will take place. Simultaneously, one is getting, instruction is getting decoded. While after it finishes decoding, it will be executed. So like this, they will all, it is a 3-step pipelining feature which is working here. Now, here again, ALU registers and you are having the control unit. So your execution unit, if it wants, the registers are also there where it can store the data as well as the result, and the control unit will do the controlling operations whichever are needed as per the program which is being executed. So arithmetic logic unit, like in the earlier class, it will perform all the arithmetic and logical operations. So this is how the complete block diagram will work. So hope you got one picture of execution which is taking place. So all the program which is present, naturally whatever program we are writing, it will be saved in the memory only. So you have to take instructions from there one by one. And then in the memory, if you have to access the data, then at which point, from which point it has to start, that is having some address. So the address is generated by your address unit. So see there, once again, one quick overflow of the whole working is the address unit is generating the physical address of the memory. Now, this is generating the physical address of the memory because the data and instructions are in the memory, and you have to fetch the data or the instructions from the memory. So the physical address which is generated by the address unit, it will be given to the bus unit to fetch the instructions from the memory. So now the bus unit will send the generated physical address to the memory. In the memory, the instructions are stored. They can be either opcode or the operand. Now, in the bus unit, we are having a block which is called 6-byte prefetch queue. So this one, I said, it is similar to the instruction queue of your 8086. So the 6 instructions, one by one from the memory, will be stored initially in the 6-byte prefetch queue. Now the 6 instructions, once they are stored in that block, in the 6-byte prefetch queue block of bus unit, then it will go to the instruction unit where they will be decoded one by one. And again, the 3 decoded instruction queue will accumulate the decoded instructions, and then the decoder will next send that particular data to your execution unit. There it will be executed. So the execution unit, it has got registers, control, and arithmetic and logical unit. So all the decoded instructions will now go to the execution unit one by one, not all at a time, and it will perform whatever operation is to be performed, or you can say the instructions are executed. So see how beautiful it is. Now, so this is how your block diagram should be discussed. If this much also you are able to write, means also it is good only. Now we will come back to discussion of the each block. So what I said just now, that same thing will be present in that also. So what all I showed in the figure, that again you have to, where is this? Wait. I am coming back to each unit now so that I will share that other slide now. So if I have also missed any point means it will cover in this. This one point I missed, I will tell you that one. So now here, each unit I have discussed. Just now what I told was how the execution is done using the block diagram. Now coming to the address unit. So just now we discussed all these points. If which point I have missed there, it will be covered here if at all it is there. So it generates the physical address. This you have heard till now many times. Physical address that will be sent to memory or IO devices by the bus unit. Now 8286 it operates in two modes. This one little you have to understand. If you understand, good only. If you don't understand also, simply you can write it can operate in two modes. One is the real address mode, another is protected address mode. Or sometimes they will also directly say that real mode and protected mode. That also they will say. Now, how these two modes are different, that we have to see. So when it is used in the real mode, the memory space which is present for it to use is only 1 MB. Actually, the memory which can be addressed in the real mode will be less. This point will also come in next 386 processor. So little bit you can understand here. And in that 386 processor, you are having three modes: real mode, protected mode, virtual mode. So there are three modes there. But how nice thought has occurred while designing all these 286, 386. That is very nice. The beauty of it is very nice. That is what I liked. I don't know about you. So real address mode or the real mode, the address unit, it will compute the addresses with the segment base register and offset. See here, if you have to calculate the physical address of the memory, then you will need the segment register and the offset registers. Now, the segment registers which you have seen in your 8086 were code segment, data segment, extra segment, stack segment. There were 4 registers. In the EIU unit, you had these 4 segment registers which were having the size of 16-bit, and they will hold the base address, and the offset address will be present with instruction pointer. IP is your instruction pointer, BP is your base pointer, SI and DI were the index register, source index and destination index, and SP was the stack pointer. So these will hold the offset address. So maximum physical space. See here, it is appearing as 4 lines there, but how to calculate the physical address? You need a segment based register and you need an offset register. So we have only mentioned here what are the segment base registers which can be used and what are the offset registers which can be used to calculate the physical address. Means the address will be present in that. If you go back and see my notes also, there I have shown one how to calculate the physical memory physical address. In that you can see the segment address and the offset address also, how it is. So the maximum physical space allowed in this mode is only 1 megabyte. So although with your 24 address lines, you can have up to 16 megabyte, but in the real mode, when it is operating, it will be in 1 megabyte. Now, you may be thinking how these modes are working, how the memory. See here, I said that 286 is the advanced version of 8086, and instructions which are used for 8086 are still used in 286, but 286 has few new instructions for it to do the memory management work here and do the multi-user and multitasking features of these 286. Now, when you switch on such a process device which is a 286, or you are switching on a computer, see, every time the advanced version is coming, you are still able to work with your old files, is it not? This everybody of us know. So initially when you switch on, here let us say, since we are talking about 286, it will be in your 8086 mode. But once it it is on, it will work in that platform for which it is designed. How do I put this one in a better way? So, so when you switch on your laptop or you switch on any smartphone also, it will go through some programs initially, some tests will go on, and then once it is ready only we will start working. So that is how in the real mode initially it is in the 8086 mode only, but after the environment is developed, after the setup is completely set in that particular system, then it will work in your 286 mode. I don't know how much you could understand by what I am telling. This is what happens actually in the device. Now, in the protected mode, the address unit acts as memory management unit, and all the 24 address lines are used, and it can access up to 16 megabytes of physical memory. So the memory space in the protected mode is more here. So as I said, initially when you switch on, it is in 8086 mode. That is why only 1 MB of memory is allowed. And then when it comes, when the environment is set and your operating system is loaded, then it is in the perfect protected mode. So it can access about 16 MB of the physical memory. All this next, the physical address of the memory for the instruction and the data which CPU wants to access will be calculated. This there is a relation for that physical address memory calculation. Address lines derived by this unit may be used to address different peripherals also. Now, since it has got the multi-user feature in it, you can also address the devices with their addresses. So suppose I give frequently this example. You are having a printer which is connected to your laptop, or you are having a fax machine which is connected to your laptop. So, or you are having an external pen drive which you will put in your laptop or your computer. So all these devices, they are all peripherals. They are different peripherals. You call it by the name peripherals. All these peripherals will be having one address. So when you give the print command, it will go to the address of that peripheral, and then the operation will take place, or the instruction will be executed. You can understand in the language like this. Now next is your bus unit. So in this bus unit, if you see the block diagram, in that the different blocks which are there, the names of that blocks, they are address latches, data transceivers, bus interface and circuitry, instruction prefetcher, processor extension interface, and 6-byte instruction queue. So if you are able at least to remember all these blocks, then to draw the figure it will be easy. If one thing you have to draw the figure, that is necessary only. But at least you should draw the blocks and show from where to where the operation is going to take place. So you have to practice this little so that you can draw the block diagram for it. So different blocks, address latches, data transceivers, because transmission and reception both will take place. That is why it is data transceiver. Address latches is whatever physical address is generated by the address bus, it can be saved in your bus unit. So that is why this latch is used. And then bus interfacing, also there is one block, bus interfacing and circuitry, instruction prefetcher, processor extension interface, 6-byte instruction queue. So these are the different blocks. To perform all the memory and IO read and write, what is the work of your bus unit? The function of the first, initially you have written what all blocks are there in the bus unit. Now next, what all work the bus unit does? It performs all the memory and IO read and write operations. So with the bus only, either you can read. Why write is needed? Because if you are performing, like if you are doing some arithmetic operation, that is a plus b or a minus b or a into b or a divided by b. Here a, b I have taken as variables, Actually, you will have data only. And then if you are performing any logical operations, the result it should be shown on the output, whether it is a monitor or you are giving it a print. Those are the output devices. So it has to write on that. Then only, or initially it will write on in the register or the memory location. From there it is going to come on the output device, that is the monitor or your printer. So that is why all the memory and IO read and write operations are done by your bus unit. So you must have understood by now what it means. Then the bus unit also does the work of prefetching the instruction byte. Prefetching the instruction byte, because it has got 6-byte instruction queue. So it has to fetch, otherwise it cannot store that. So that is why it has to prefetch the instruction bytes, then transmit the physical address. So all these work you are familiar, but you have to write it. Then only the work of bus unit will be done. So transmit the physical address over the address bus A0 to A23. So whenever the bus unit is not using the bus for the operation, it prefetches the instruction byte and put them in the byte prefetch queue. So it is understandable only, nothing is new in this. Prefetcher module in the bus unit performs this task of prefetching. So earlier what all I showed, I spoke about the block diagram also. Now since you have understood that, one by one point you can write for each unit. Prefetcher module in the bus unit performs the task of prefetching. Bus controller controls the prefetch module. Obviously, is it not? Since the prefetcher is there in the bus unit only, the bus controller only will control this one. Fetched instructions are arranged in the 6-byte prefetch queue. So this is about your bus unit. Now, it is easy only. Only thing is you have to practice it. Now, next one is your instruction unit. Only 2 blocks are there in instruction unit. It is very easy. It has instruction decoder queue and instruction decoder. So in the instruction decoder, one by one instruction will come and it keeps on decoding, and then it is stored in your decoder queue. 3-byte instruction decoder queue, one block you have seen in your block diagram. So it fully decodes the prefetched instruction and holds them in a queue so that the execution unit can access them. So once it is in the queue, then only the execution unit will be able to access them. It helps the processor to speed up as pipelining of the instruction is done. So in this case, I told earlier also that at one place prefetching is done, another place decoding is done, another place execution is done. So they will not wait for each other. One by one, everybody will go on doing their work. So that is why the pipelining feature has increased the speed. So in the beginning, we have seen the speed has increased 6 times when compared to your 8086. So you see 6 times to increase the speed. How much of advancement should be there? Now, instruction decoder decodes the instruction one by one, and they are latched onto a decoded instruction queue. Then execution unit. Our last one is the execution unit. So till now we have seen address unit, bus unit, instruction unit, execution unit. So in the execution unit, if you remember the block diagram, or you can see if you are having it by your side, it has arithmetic logic unit, register and control unit. Now registers are general purpose register. This I have given in general. A little later I will show you what are the different registers also. Registers are general purpose registers, index pointer, flag register, 16-bit machine status word. It is also known as MSW, machine status word. So if you remember that full form only, it is better, because you are close to your exams also now. Short forms will not help you to write that one. So ALU is the arithmetic and logic unit, is the heart of the execution unit. So every time ALU will be heart of the processor. This time it is heart of the execution unit. So that is the beauty here. To sequentially execute the instructions received from the instruction unit. The work of your execution unit is it has to sequentially execute the instructions received from the instruction unit. Control unit is responsible for executing the instructions received from the decoded instruction queue. So see there, registers, they are used to save the instructions, and it can save the data as well as the result also. The control unit is trying to manage how the execution of the unit is done, and the arithmetic and logic unit will execute actually the instructions. Then it contains the register bank. What contains execution unit contains the register bank. Registers, one block only is there, so you can say it is containing the register bank. So after execution, ALU sends the result either over the data bus or back to the register bank. So this we know already only, and I told you also, result should go somewhere. So either it has to go to memory. If it has to go to memory, it has to go through the data bus, and then it has to go through the address bus to that particular location. And then, or if you want, you can also store in the register bank. Now, just now I was discussing what were the registers of 286. What all registers are there? I told earlier also when we came across the physical address calculation that you need segment registers. Now, 4 segment registers are there: CS, DS, ES, SS. 16-bit registers. If you still remember the block diagram of 8086, you had all this in your EIU unit. And then you are having 8 general purpose registers. See, sometimes they may ask you, write about the registers of 8086 or write about the registers of 80 to 86. Then you have to write about all these registers. You have to write their name. You have to write what is the size of that register. So depending upon whether it is 8086, then it is where it is. Whether it is in your EU unit or it is in BIU unit. Similarly, if it is your 286, in which unit it will be. That you have to remember the block diagrams, and depending upon that, you can write about the registers of that particular processor. So this is same only. The names of the registers are same, but where it is present, what is the size, that you have to remember. So 8 general purpose registers, each of 16-bit size. This I am telling so many times. So by now you must have got by hearted also, I hope. So these are general purpose registers are AX, DX, CS, BX. Then BP, these are all pointer registers. BP is base pointer, SP is stack pointer. Now in exam, if you can write the full form BP, SP, SI, DI, then the person who is correcting will be very happy to know that you know so much. So base pointer, stack pointer, then source index, destination index. Now here also this point, whether it is 16-bit size. Now this your BP, SP, SI, DI, they have to be used as 16-bit only. But for AX, DX, BX, CX, ABCDX, if I can say AX, BX, CX, DX, they are 16-bit, but you can use them as 2 8-bit registers also. AH, AL, similarly BH, BL, CH, CL. So you can use it for the size of 8 bits also, or as 1 byte register also. If you are using only 1 byte, what will happen to the other thing? It will be loaded with zeros. That will be by default. So these 16-bit registers can also be used as 8-bit registers. Now 4 segment registers, they are also 16-bit. Now one thing here which although you can use AX, BX, CX, DX as 16-bit, you have the option of 8-bit. But since it is a 16-bit processor, you can, mostly it will be used for the 16-bit calculations only. Then one more new thing here, that flag register only is your program status word. So don't get confused. what is that flag register? Earlier in the features I told flag register is also 16-bit, and out of which only 12 bits are used and 4 are unused. So that is how the flag register are. Now next one is two status and control register means it is flag register and the instruction pointer. That is your the status register is nothing but your flag register, and control register is your instruction pointer. We have given it some special name as status and control registers. Now this is about your block diagram. The same thing is discussed in your material also. So if you are happy with your material, you can read that also. Very nice information they have given. Now what are those? We discussed that it has got 68 pins. Now in these 68 pins, there are some special pins here. Like you can see your material also 266 page number. For me it is 266. You check around that only it will be for you. Other than the clock, data, address, all this, you will have some BHEL, bus high enable. So they have given some special pins, that is PEREQ, processor extension request, then PACK, processor extension acknowledge. So these I told you earlier also that apart from the instruction set of 8086, they are having some new instructions also. So for those to execute, you should have some special pins also. So that is how this processor extension request, processor extension acknowledge, processor extension busy, processor extension error. These are the few new things which are included in your 286 processor. So this is all the story about 286 processor. Now, if you have anything from your side, you can ask.
Ma'am,
Yes.
in textbook page number 268, flag register of 8286. There are some tables. What is that?
That is same, no? See, what table? That is only registers are shown in the form of figure. Complete register set, no?
Okay.
Now my slide is showing registers of 286. That same registers they have shown in the figure. You see properly.
Okay.
See there they have apart from showing AX, BX, CX, DX, what work these registers are doing. See in your material only you can see AX and DX, they are used to multiply and divide. And divide operations, IO instructions. Or they are used for IO. Similarly, loop shift, repeat count, loop shifting is done through those registers. Now, similarly, base registers are used for your physical address calculation. Index registers and string pointers. So, in your 8086, at some point, we have discussed about the strings also. One point has come. If there are string, then how to see the starting address and the ending? String means it is a group of numbers, is it not? And how will you store? Suppose you want calculate the square root of some 10 numbers they have given. Calculate the square root. Means 10 numbers means it will become a string there. So how do you save that? Or moving a block of data from one memory location to another. They are all strings. It is not to do with only two variables there. There you will have variables which are more than 2. So you call them as a common name is given as a string. So that is what it is showing. Even if you see, if you don't draw or write so much what is there on that page, at least you can say how many general purpose registers, how many segment registers, what are the other registers in that. How much you can remember, that much only you can reproduce. No, more than that it is not possible. Now in that
in their page, they mentioned some numbers. Those are nothing but pin number, na?
no,
40,
which one?
39,
Which one?
47. Page number 268 only.
No, it is not pin number there.
So what's
See, all these segment registers, if you remember in 8086, each segment register, it will have a size of 64 kilobytes. Do you remember that point? So what is the starting value? What is the ending value? Which can be accommodated in that particular register, that they have mentioned as some numbers there. You don't go into the details of all those things, because see, actually 64 kilobytes, 64, it is into 4 segments: code segment, data segment. So segment size, if you talk in terms of 8086, segment size is 64 kilobyte. Segment base address means, if you say 64 kilobyte, now I can explain this with a general example. Suppose you are dividing one 200 pages notebook into 4 sections. In the first one, you will write classical mechanics. Second one, you will write statistical mechanics. Third one, you will write EM theory. Fourth one, you will write about the microprocessor and memory devices. So from where to where, which subject is there? First, first 50 pages, your classical mechanics is there. Next, from 51 to 100, your quantum mechanics is there. So each one will have, each division will have starting and ending address, is it not? So the base address should be given for that memory location. That is what it is explaining by those numbers there.
okay then?
In the page number 268, this one is no need to write in the examination.
And you don't discuss about the access rights. See, access rights also, some websites will be accessible for us, is it not? Some you are not, they are not accessible. So then you cannot, although you will try to click on that link, it will not open unless it has got its code. You put the code, then only it will open. So all your, we will get one time OTP password, is it not? If we put the password, only certain things will open for us. So that is what is the access rights there. If you are interested in writing, you can write, but discussion of that may not be necessary, I feel.
Ma'am, in the assignment, the question is asking 80 to 86 flag registers, but in the material not given, all are writing 8086 flag register. That one also correct, ma'am?
Yes, you can write. Yes, you
Okay,
can
ma'am.
write that. Because
Today,
this is advanced version of
yes,
8086,
ma'am.
and flag register in this case also is having only 12 bits. 4 bits are not used.
As like that on also
There
all are
also it is
writing.
same only.
Okay,
So you
ma'am.
can write that one also.
In today's class, we are discussing one is the architecture. That one is asking one question, and there is the
Architecture,
pin
or
configuration.
see, listen. Architecture or block diagram, it means same.
Same.
Yes.
Another one is pin configuration. They are asking
Pin
80
configuration means, see there, I think pin configuration is given in your material. Pin configuration, wait,
Yes,
I think
ma'am.
I saw that one. See, in your
267.
page number 267, pin configuration is there.
Yes, ma'am. They
So
are
in
asking, we
for
have
that,
to need to write pin configuration with diagram and clock D15 to D0. These all much we have to write in the examination, ma'am.
but in this
Additional features.
only what the function that particular pin is doing, it is writing. and it is mentioned whether it is an input pin or an output pin.
Yes.
See how much is there in your material, that much you try to write, that will be enough.
Okay, ma'am.
Because no, I think that writing this much only would be more for you in the exam.
They are asking only architecture and block diagram.
One more point I have to tell you people is, I don't know whether you know or no. Now with everything going online, you
Yes,
first, before writing the answer, you have to decide which answer you know very well. Now suppose in one question you will have an internal choice. Generally it will be in the long answer type of questions. Long answer questions means it will have A and A or B. I think that is the pattern, or they will say 5 or 6. I don't remember now the pattern. So if there is an internal choice, by internal choice you know what it is. Long answer will be there. They will ask one question and then or another question. One more is with it. That is known as internal choice.
Not given internal choice, ma'am. 10 questions they given, right to the.
Any 5 they will say, no?
Yes, ma'am.
Any 5 means you decide which you know well. And even if you write more than 5, then for whichever answer you will get more marks, that will be counted. And for which you are getting less marks, that will be left out like that.
Ma'am, I am asking, they asking architecture and block diagram. Only we draw the block diagram and explain the each unit only.
Yes,
If they are asking
yes.
pin configuration, we
Then draw only pin configuration.
Pin configuration only we have to explain.
Yes,
Or
yes,
they
yes.
are asking flag registers, flag register
Only that much. Right.
Yes. Okay.
Now, one more thing I want to tell, pin configuration when you are writing. So it will have the pins of all the data bus and the address bus. See the figure which is there in your,
Yes.
in page 267 figure is there. You can see there all the data pins are given numbers from D0 to D15.
Yes, ma'am.
On that same line VCC is there.
Yes, ma'am.
And then although in your material I don't know whether 16 bit of data lines is there. So after drawing the pin diagram also you have to put that in words. That you know, I think.
Yes,
Just
ma'am.
like you draw the block diagram, then you explain each block. Similarly, pin diagram also you have to draw and then explain about the pins. 1 or 2 if you are forgetting also no problem. 1 or 2 if you forget to write also no problem. But maximum pins you have to try to write. So this pin diagram is actually very easy. They have simply given one tabular column and familiar pins only it is written in your material. So maximum number of pins you try to write about them. Right? Hello?
Yes, ma'am.
Yes, ma'am.
52 pins are there, ma'am, in this pin configuration.
68 should be there. I did not count, but there are 68 pins in this. I will also once again check and then tell you whether it is correct or no. Shall we stop now?
Yes, ma'am.
Yeah, if you are having doubts now, you write it on a paper and keep so that you can ask me in the class.
Okay.
Because with all the work which we are all going through, it is possible you may forget. So you can write and then you can ask me.
Ma'am,
Huh?
instruction set of 8086 we have to write from 243 page to 249, ma'am. 250 ma'am.
43.
Instruction set of 8086, ma'am.
So if it is your assignment, see all this information now you cannot write in the exam. You will not have so much of time. So when you are preparing, you prepare in the examination point of view. It is not necessary that I told this in the last class also. You have to explain all the instructions. If you can write, simply give a list. List means I will tell you, wait, what is meant by list. If you are explaining in that, you explain generally in the list means, see here, page number 248, you see, 248.
Only headings and full
So
form.
all that which is there no, in the dark color,
Yes.
that is list. And
Yes.
if you are explaining, then you have to explain like it is in 242 page. See 242 page or 243 page you can see. Data transfer instructions is there. Are you seeing?
Yes, ma'am.
243 data transfer instruction. You see,
Yes.
they have written
Yes.
move. And then how that move instruction can be used, they have given some different examples. So you have to write the syntax and then explain how that instruction will work. And you can give 2 examples, that is enough, or at least 1 example showing the opcode and the operand.
Move AX, 5000H is enough, ma'am.
Yes, yes, at least 1. Whichever is easy for you, you give that.
Yeah.
Okay?
Okay.
Okay. Okay, so we will stop now.
Yes, ma'am.
You take some rest because continuously it is not possible to listen. Okay?
Okay, ma'am. Thank you, ma'am.
Okay. Thank you all.
Thank you.